3-point charges are located at the corners of an equilateral triangle as in figure P1513. Calculate the net electric force on the 7 microcoulomb charge. Okay, so first I drew a diagram and I drew the forces that are acting on the 7 microcoulomb charge. Because this charge is positive and this charge is positive, they're going to repel and the force will be in this direction, and I labeled that force 1. And because this charge is negative and this charge is positive, they're going to attract, and I labeled that force 2. For this problem, what's really important are the x and y components of force 1 and force 2. So I drew a second diagram noting what the x and y components for both those forces are. And these angles come from here, so you can see how I got those. And next I found force 1 and force 2. So for force 1, I plugged in the values and I got 0.504 newtons. And then for force 2, I plugged in the values and I got 0.008 newtons. I then drew another diagram just labeling the x and y forces, and I label my positive and negatives, and then I summed up the forces in the x and in the y. So in the x you have 0.504 cosine 60 plus 1.008 cosine 60, and that's equal to 0.756 newtons. And then in the y you have 0.504 sine 60 plus negative 1.008 sine 60, and you get negative 0.436 newtons. I drew one last diagram just labeling the net x and the net y, and I did Pythagorean theorem to find that this net force is 0.873 newtons. And then I did a tangent ratio, and I found that this angle is around 30 degrees, and so the answer is 0.873 newtons, 30 degrees below the positive x-axis.